In this video, we're continuing the application problems from the homework on greatest common factor and least common multiple. So let's read the question. Paige is buying hot dogs and buns for a family reunion. Each package of hot dogs contains 8 hot dogs, and each package of buns contains 10 buns. So here's our question. What is the least total amount of hot dogs and buns she needs to buy in order for the amounts to be equal? So if she just bought 1 package of hot dogs and 1 package of buns, notice she'd have 2 extra buns. So we want to find the least she needs to buy so that she has an equal amount of hot dogs and buns. So let's make a chart. So we'll put number of packages. And now we'll find the number of corresponding hot dogs for that package. I'll use HD for hot dogs, and the number of corresponding buns for a certain amount of packages. Okay. So let's start with the hot dogs. So 1 package of hot dogs would be 8 hot dogs. 2 packages would be 16. 3 packages would be 24. 3 times 8. So basically I'm just adding 8 each time. 4 packages 32. 5 packages 40. I'm going to go up to 7. Then we have 48. 48 and 8 is 56. Okay. So here's some corresponding number of packages and how many hot dogs that would give her. So now let's do the same process for buns. Well, if she bought 1 package of buns, that would be 10. 2 packages would be 20. 3 would be 30, 40, 50. So I'm just counting by tens, 60, and 70. Okay. So now what we want is an equal number of hot dogs and buns. So looking at this chart, well, we have 8 hot dogs. That doesn't correspond. 16, nothing matches up. 24 doesn't match up. 32 doesn't match up. And now we have 40. So there's a way to buy packages of hot dogs and buns so that we have 40 hot dogs and 40 buns. So 40 hot dogs and buns is our answer. How many packages of hot dogs will she buy? Well, 40 hot dogs corresponds to 5 packages. How many packages of buns will she buy? Well, 40 buns corresponds to 4 packages of buns. Okay. And again, this is the least amount of each she can buy in order for the amounts to be equal. I bet you'll agree that if she bought twice as many, so 10 packages of hot dogs would be 80, 8 packages of buns would be 80, we'd have as many different corresponding amounts of equal hot dogs and buns as we'd like. But we were asked to find the least amount, which will be 40. And notice that what we did here was find multiples of the number of hot dogs and the number of buns, and we found the multiple, the smallest multiple that matched up, which is the least common multiple. So that's what 40 represents for both 8 and 10. 40 is the least common multiple. Okay, let's look at one more problem. Maureen is planning a party. She has 156 candies and 168 toys to place in party favor bags. If she needs each party favor bag to be identical, here comes the question. What is the greatest amount of party favor bags that she can make? Okay. So you're probably starting to see the patterns here. It's asking us for the greatest amount, so this is going to be a greatest common factor problem. But we're going to start by finding all the factor pairs for 156 and 168. So let's get a pen. 156. Okay. So first, this would be the number of bags. and this would be the number of candies per bag. So if we have one bag, that one bag would have 156 candies. Okay. If we have two bags, well, dividing 156 by 2, I know it goes in because this number is even. I'd have 78 candies per bag. Okay. So now I'm going to continue and find all of these. So I use the process of finding all the factor pairs to find all the factor pairs up to 12 and 13. And now notice reversing this. We can reverse these factors, and here it makes sense to do that because this represents a number of bags and this represents a number of candies. So let's put that right here. And now we have a list of all the possible number of bags that would give us a whole number amount of candies where each bag has the same number of candies. Okay. Now we need to do the same thing for the number of toys, 168. Let's change the color. So for 168, we would have the number of bags and the corresponding number of toys. That looks like it says togs. Okay, so now we're going to follow the same process of finding all of the factor pairs. So here is a list of all the factor pairs of 168. Okay, and again, we can reverse these because the first number corresponds to the number of bags and the second number corresponds to the number of toys. So let's write all those reverse values. Okay. So now we know all the ways that we can break up the candies into an equal number of candies per bag without any candies left over, and the same for the toys to place in the party favor bags. So now we want to find the largest number of bags that both the toys and the candies can be broken into. So I'm going to get a highlighter ready. Okay, so here are the number of bags for the candies that are possible. And here are the number of bags for the toys that are possible. Okay. So I'm going to find all the numbers that correspond to each group, and then our goal is to find the greatest number. So there's a lot of information here, so you want to be systematic. I'm going to start with 156's factors, and I'm going to scan through them and then check to see if they also correspond to 168. So 1 does. 2 does, 3 does, 4 does, 6 does. Let's see if 12 does. Oh, there's 12. Going to the next column, 13 does not match up, 26 does not match up, 39 is not in the list, 52 is not, 78 is not, and 156 is not. So these are our common factors, okay, for 156 and 168. So these are the number of bags we can make that satisfy the criteria. And in addition, since we want the greatest amount of bags that can be made, we would take the largest number in this list, which is 12. So she can make 12 party favor bags. Now we have 2 more questions. How many candies will be in each bag? Well, here's our candy information. If we have 12 bags, each bag has 13 candies. And how many toys will be in each bag? Well, if we have 12 bags, there will be 14 toys per bag. Okay. So again, that's the greatest common factor problem. Okay. And you can find the greatest common factor using Venn diagrams or prime factorization, or you can make these lists like we did here. As long as the problem makes sense to you, writing out this information really shows us why we're finding the greatest common factor. But once you understand that, you can definitely find the greatest common factor in a quicker way.